my name is Ricardo, and I'm your host of Math Matters. And today we're going to be discussing the golden ratio. Specifically, what the golden ratio is, what it means in mathematics, how it's defined, and how we can use it in a short example. So first of all, what is the golden ratio? The golden ratio technically is a fundamental mathematical constant. And that's just a fancy phrase for it's a number. A number that's an underlying fundamental factor in an overarching principle. So our overarching principle is the golden ratio, which we'll talk about what it means and how it's relevant even later on. And the constant, the number that's underlying to the principle, is the ratio. Now this ratio is a literal number, but this number doesn't really tell you much about the principle or doesn't give you a lot of understanding. Memorizing the number, you can memorize it all you want, but it's not going to prove you know and understand what this concept means. So what is an example of a fundamental mathematical constant? These numbers, these fundamental mathematical constants, are present everywhere. A really good example of a number that is important in our society is 3.14. Now, 3.14 is a very common number. It's taught in a lot of schools, and I hope some of you recognize it as pi. Pi, or this Greek symbol here, is one of the fundamental mathematical constants. Now, fundamental mathematical constants, or these numbers, are given Greek symbols because they're just deemed so important and so applicable that we can always refer to them with their specific Greek symbol. And this is a very commonly known one, so whenever people see this Greek symbol, they usually know this is the number we're talking about. And it is a repeating decimal, so talking about the number isn't always convenient. You just talk about this one symbol, you automatically know this specific repeating decimal. Now pi itself is really important because we can talk about circles, or really roughly drawn circle. And whenever we want to quantify, measure, talk about different circles, pi is always involved because it's the ratio of, two aspects of the circle. Now, I'm not going to talk about circles, that's not, the point of this segment itself, but it just goes to show one example of a fundamental mathematical constant. Now, what is the golden ratio? The golden ratio, just like pi, is a never-ending decimal. So first of all, let's write the number, the least important part of this concept. So the number itself is 1.618. And that repeats, like I said. I'm going to write ... and put it in this box, just so we remember it's up there. Now this number itself doesn't tell you, what the golden ratio means, how we can use it, and memorizing it isn't really going to help you understand that, but it is good to know such that whenever we talk about the golden ratio, you have that in the back of your mind. So like I said, pi has a Greek symbol associated with it just because it's deemed important, right? We see circles throughout our society, like in circles, in gears, the circles in gears, the circles in wheels, the circle in nature even. It's just throughout all aspects of our lives. That's why it's deemed this important. But phi itself is also deemed important. We'll get to how it's important later on. But the fact that it has a Greek name kind of gives that impression, which we'll again discuss later on. And it's called phi. Now the golden ratio is phi. Phi, just coincidentally, is close to pi, is another Greek symbol. This Greek letter looks like that. Just a circle with a line right through it. It can also be written as like this. If you see it in some textbooks, it's written like that. But I'm going to be always writing it with a circle and a line right through that. So this is phi. But this alone, knowing the Greek symbol, knowing the number, knowing it means the golden ratio, does not tell you anything about the golden ratio, and it doesn't really enhance your understanding of it. Let's talk about what the golden ratio means. Just like pi is involved in geometry, with the circle, as I showed, the golden ratio is heavily involved in geometry. So here I have a segment, I have a line that I drew. Now, the golden ratio occurs in a very specific scenario in geometry. So you have a line segment about this tall, called A. Now the golden ratio occurs when I say, I want to divide this line not in half, not in a third, but at a very certain precise ratio, 1.168 or 1.1618, such that the larger division divided by the smaller division, or the ratio of the larger division to the smaller division, is equal to the whole segment to the larger division, or the ratio of the whole segment to the larger division. Now seems like a very coincidental and abstract definition, but let's write it down and we'll discuss it a little more afterwards. So it says essentially A divided by B, where A is the whole segment, as I drew over here. A is the whole segment, B is the big part that you took off. When you split it, it's the bigger part. This ratio of A to B is equal to B to C. And when that is true, when A divided by B is equal to B divided by C, the golden ratio is present. These two are ratios, right? A divided by B is a ratio, B divided by C is a ratio, and when they're equal, they're both equal to this golden ratio, or 1.618, phi. Now this is a general scenario, and that's how we define the golden ratio. How you can split a segment so that you have the golden ratio inside of it and the same ratio outside. Inside ratio matches the outside ratio. That by itself is a pretty cool concept, but it's very difficult to understand, and it doesn't really mean much until we're able to apply and calculate it, right? So, the one way to apply it, and one way that kind of demonstrates how cool and interesting it is and even applicable, is through the human body. The golden ratio is seen throughout our society, but one really cool example of it is the human body, humanoids in general. The human body is divided in two sections, the upper and lower half. Even though we call it upper and lower half, it's not really halves, because the upper half is usually a little shorter than the lower part. Now, if we define the upper part of the human body as from the belly button up, and the lower part from the belly button down, the lower part is a little longer than the upper part, and on average, it turns out that this human proportion follows the golden ratio. That means if we take the measurements, from the belly button to the floor, from your belly button to the floor, and from your belly button to your head, those two are your B and your C, such that your whole body to your lower body is the same ratio of your lower body to your upper body. That's cool, and that's really interesting, but it doesn't mean it applies for every individual. In fact, I measured myself, and I found that this ratio for me was about 1.7. Not so close to the golden ratio, not too far either. Remarkably close, in fact, considering how much can vary in a human body. But it doesn't necessarily say anything about me. Perhaps I have longer legs than, I guess the average, but it doesn't say necessarily anything about, humans in general. It's just really cool how we follow a ratio close to that. And on average, people have a seemingly close ratio to this golden ratio. That could be coincidental, however. But just to show how we can calculate it, and just to show one, easy visual example, I'm going to use my upper body. Now let's just take my upper body, which is in the frame of this video. Let's take my upper body, meaning from my belly button to my head. Let's make that my A. And yes, I did draw this very strategically, such that the whole segment is my upper body. Now let's divide that into my head and the rest. So if my head is from my Adam's apple to the top of my head, that's my segment C, and my segment B is from my Adam's apple to my belly button, or about the interior of my elbows, where my belly button is. But so this whole thing is my upper body. This is the bigger part, my torso essentially, and this is the smaller part, my head. So I measured these in centimeters for myself, and I encourage you to do the same. It's a nice activity, it's pretty cool. And it turns out my head is about 23 centimeters tall, and my torso is about 37 centimeters long. Well, this is our B and our C, right? We have our B and C. Let's see if this follows the golden ratio. In order to determine whether our B over C follows the golden ratio, we plug in the measurements I just received. So, our B is 37, divided by our C, which is 23, we have 37 divided by 23, and that's the ratio. So let's take out your calculator and plug this in. 37 divided by 23 is about 1.608. It's actually 1.608 over 1, but I'm just going to write the top part. That's the number I'm looking at. That can change. That's really close to 1.618. Well, what about our A or B? Let's confirm that they're about the same. If our B is 37 and our C is 23 centimeters, because our A is these two segments together, we can add it up. 37 plus 23 makes our A 60 centimeters. And I did measure my upper body just to confirm that the whole upper body is 60 centimeters. We have this new ratio, A over B. A over B, where A is 60, right? B is 37. We can calculate that the same way. Plug it into your calculator. We get 1.622 about when you round. So this is also really, really close to the golden ratio. Now this is about 1/100th or 0.001 less than the golden ratio. This one's about 1/100th more than the golden ratio. So if you average these two measurements, or these two ratios of my body out, you'll find that they average nearly exactly to the golden ratio. And that is no coincidence. I found that, several measurements were pretty close. This is an unusual close measurement. It doesn't mean anything about my upper body. However, the precision of these, considering how much can go into the factors of a growing human body, the precision of these numbers really show that the golden ratio is no coincidence. Here we see how it can be calculated, but the fact that it can be applied to, such a natural thing as human growth does show that the golden ratio has some significance, and that's the significance we're going to explore in the rest of our videos. Hi guys, thank you so much for watching my video. It really does mean a lot. And if you enjoyed this one, I encourage you to watch the next video in my series. And hey, if you're done with the series, there's always more mathematics to learn. Because remember, math matters.